By the end of this video, you will learn how to build AI applications that answers questions from your own data. Yes, you've heard me right. This can be data from your database, data from PDF files, unstructured data, data from your website, whatever source your data may be. Guys, trust me, that's my hope. We are going to build everything from scratch. If there is one skill you could master in 2024, is how to build AI applications using Retrieval-Augmented Generation. By the end of this tutorial, you'll be very comfortable building your own AI-powered applications using Langchain. Ready to do it? Let's get right into it. So before we get started, we have to make sure all these libraries we'll be using are properly installed and they are working. So for that, I've listed all the libraries we need for this particular tutorials in a requirement.txt file. So you just need to go ahead and do pip install requirement.txt. So over here, I'll just open the terminal and open a new terminal. And over here, I can close this up a little bit. And all I'll do is to first activate my virtual environment. I've created a virtual environment called bot, so you guys can go ahead and create a virtual environment. I have a tutorial on how to create a virtual environment, so in case you can't, just watch it up. The link will be in the description. Okay, so I'll go ahead and activate this virtual environment. I will type the name of the virtual environment -script, activate. And this will go ahead and activate the virtual environment. Now I can go ahead and just write pip install -r and the name of the requirement file. So it's requirements.txt and hit enter on this. So this will install all the necessary libraries we need for this particular tutorial. If you can see, I've already installed this library, so it has just given me requirements already satisfied, and that's it. I can now close the terminal and close the requirement file. And over here, there is one thing you also need, which is an API key. So you need GPT API key because we'll be using GPT 3.5. So you need an API key. You need to create .m file, so .env file, and write OpenAI key, and then paste in your API key right here. So I'll paste mine, but I don't want you guys to see it. So just write this and paste yours in the name .env file. So you just have to go to new file and do .env file or something. I've done that already. Then right after doing that, you write OpenAI API key is equal to, and you paste in your OpenAI API key right here. If you don't have one, you can just go to openai.com and sign up for an API key. Right after doing that, let's go through what we'll be building today. So I have a diagram representation where we'll go through and know what we are actually going to do. This diagram is a RAG-based system. So we start from one, and one here is a query from you, the user. So we are going to build a system that will take prompt from you, a user. Let's say you are going to give it a question, and then to convert this to embedding. So this will be like numerical representation of your query, and this will go into your database. So you can see from 1 to 2 and from 2 to your vector database. So before your LLM or your model will answer you, your question needs to go to your database and retrieve all the important information related to your question, and this will be retrieved back to your LLM, and your LLM, based on that context, is going to generate you a response. So in our case, you ask a question, the question goes to your database, and this your database contains your PDF files or your data. Based on your question, your LLM will retrieve the data that correlates with your question or your prompt and then give you a response. Okay, so in this vector database, you have your PDF files, you have your informations which you want your LLM to answer questions based on those informations. So this is the kind of system we are going to build today, and this is totally a RAG-based system. So these are the things you will need in order to build this system. You will need a PDF file. So right here, I have a PDF file. And this PDF file is just a brief information about malnutrition detection using convolutional neural networks. So we'll be answering questions based on this PDF. Our LLM has to answer questions based on this PDF. So this is the context we'll be providing this LLM. Anything outside of this context, it will do its best not to return us any answer, because we want it to mainly focus on the context we are giving it, and that's what RAG system is about. The LLM answering questions based on your data, based on your additional data source provided. In case it has no idea about whatever you are asking, it has to return that okay, it doesn't know what you are talking about, and you should come out with questions related to your context provided. So we'll be loading this PDF file into our vector database, and then our LLM can now go ahead and answer questions based on this PDF. So at the end of this tutorial, all these files will be made available on my GitHub repository so that you guys can download it and experiment with it. All right, so I think these are all the files we need. These are the necessary files we need. So I can just go ahead and create IPython notebook. So I'll call this main.ipynb, which stands for IPython notebook. I can close the terminal and also maximize this place so that we'll have a lot of space to work with. So the first thing I'll go ahead and do is to import so many libraries we'll be using from Langchain. So I'll import them. Then as we are building along, I'll be explaining what each and every import is doing. So I think with that, we can be able to understand why we import some particular library from Langchain. So I'll paste this right here, and then I'll go ahead and run this cell. Okay, so we got a success message. You can see the success mark right here, which shows that everything is working and we've correctly imported all our necessary libraries. The next thing we'll go ahead and do is to load in our API keys in order to access this large language model. So I told you guys we'll be using the GPT-3 large language model from OpenAI. So what we'll do is that you have to type load.env, and that's it. So we've imported this right here. So from .env we are importing load.env. So you have to just create an instance of the .env library here, load.env, and this will help us to load in our API key. So now you've understood why we've imported this library already, because we are going to use it to load in our API key. Our API key is equal to, we'll use the OS library, so os.getEnv, and in here we'll pass in the name of our API key. So from the beginning, our API key, we've written it in the .env file as OpenAI API key. So this is the name we've given to the API key in the .env file. So you have to type the same name here, and then we can read in that API key and we'll be able to use it. Another thing I'll specify right here is the model I'll be using, because GPT have different models. We have GPT-4, GPT 3.5. So we'll be using GPT 3.5. So I'll go ahead and specify that my model that I'll be using right here equal to GPT 3.5 Turbo. So this is the particular GPT model I'll be using, and with this line of code we are able to initialize all these stuffs. So we've loaded our API key, and we are now saying we'll be using the GPT 3.5 Turbo model. That's good, and we are cool to go. The next thing we have to do here is to make sure this model is working. So we have to make sure we bring in this model and test this model and see whether it's working before we continue to build our RAG based application. So for that, we can say our model is equal to chat OpenAI, and inside here we provide our API key. So we can give it our API key. API key is equal to our API key, and over here we can specify the model as well. So the model we'll be using is equal to the model we've initialized ahead. Our model right here is equal to chat OpenAI, because it's a conversational model. In here we are giving it the API key, and you can see we've specified that here. We are also giving it our model, which we are specifying that we'll be using the GPT 3.5 Turbo model. Okay, so this chat OpenAI we are using here, we've imported it at the top. So you can see from Langchain OpenAI.chat models, we are importing chat OpenAI. So that's why we are using it right here. So now you understood this import as well. And once we are using them one by one, these lines right here will be going. If you import and you are not using it, it will have some line under, and that's one of the great ways you can know whether the library you've imported you are using it or not. Okay, so everything is working so great. Now we need to invoke this model to see if it's working. To invoke means to just give this model some prompt and see whether it will return to us some answer. So we can just say our model dot invoke, and right here we can type in maybe what is coding, and let me run this cell and let's see if it returns something back to us. Okay, so you can see this returns as an AI message, and the content is coding is a process of creating instructions for computer to follow to perform that. So our model right here is working. As you can see, our GPT model is working, but there is a problem because this is returning as AI message, and what we need right here is not AI message. We only need the content. We need coding is this, and that's what we are interested in. All the other things is returning to us, we don't need it. Giving us the model name, the system footprint, we don't need that. All we need is the content, which is the answer we request from the model. Okay, so to do that, Langchain have something we call string output parser. So for that, we've imported it at the top. You can see from Langchain we are importing string output parser. So I can just copy this and I will say, okay, my parser right here is equal to string output parser, and that's it. So together with this parser, I can chain this my model, and this model will now give me only the content in the response it returns. So I'll call this chain, and this my chain is equal to my model. So I have instantiated the model here, and then the output from the model, I'm passing it through the string output parser in order to give me only the content. So this is the beauty of Langchain. Langchain, as the name suggests, deal with chains. So you are chaining different outputs together. So right here, we will take the AI message from our model and chain it together to the string output parser we've imported, and this string output parser will give us only the content. Okay, so if I should do chain dot invoke, and right here I should pass in the same kind of text what is coding, I expect this to only give me the content and not an AI message. So let me quickly run this. Okay, name error, chain is not defined. Okay, I didn't run this cell, so let me go ahead and run this cell and then run this once again. Okay, wow guys, so you can see now we only got coding is the process of using programming language. We are not getting an AI message again. We are only getting the content that's here, and that's the string. So this is how powerful Langchain can become. This is how powerful Langchain can help you to chain different outputs together. So you can see now we are getting the answer, and this looks great. Okay, so the next thing we'll go ahead and do is to read in our PDF file, because we are not interested in whatever answer this large language model will be providing us. What we are interested in is this large language model answering questions based on our context we will provide. Okay, so for that we have to first read in the PDF file and tell it, okay, you are going to answer my questions based on this PDF file, based on this context I'm going to give you and nothing else. So that's what we have to do next. So over here, to load the PDF file, I can just say file loader, and this file loader will be equal to PyPDF or PyPDF loader, and inside here you need to give it the path to your PDF file. So when we come here, the name of our PDF file is right here. We can copy the path, copy the relative path, and just need to paste it right here. So you give it the path to your PDF file, and this will go ahead and do the magic by loading every single page in that your PDF file. Okay, so we'll go ahead and say our page here is equal to file loader dot load and split. So this will load in our PDF file and also split them for us. So for instance, if we should do page here, this is going to list all the pages in our PDF file. So PyPDF, we are using PyPDF loader because we've also imported it right here. So you can see PyPDF, and this is from the Langchain community .document underscore loaders. So we've installed all these packages and they are in the requirement.txt file. Make sure you install them properly before using them. So we are using the PyPDF loader to read in our PDF. Let me now run this cell and let's see whether it's reading in all this PDF in the right way. So you can see it has read in all this PDF and into separate pages, and you can see there is very long. So this is how it reads and splits your document. You read this document in a Python list and split them into different pages. You can also check the length by doing length of your pages to see how many pages it has read. So this is about 7 pages because this document we are using right here is very small, it's not huge. So in case you have a very huge PDF file, it can be PDF file about your company, of any data you want to use it with, you can just follow the same steps and just give the name of that PDF file right in the code. Okay, so this has read in our PDF file and now we are cool to go. We have to now split this PDF file into different chunks so that we can send this right into our vector database. So for that, we'll be using recursive character splitter, and this is from Langchain. So we are importing recursive character splitter here, and that's what we'll be using to split our PDF file into different chunks. So we'll be splitting it into smaller chunks so that we can save it into the vector database. So we'll call this splitter, and this is equal to our recursive character text splitter, and in here we'll give it our chunk size, so we can specify our chunk size. And for now I'll just put a chunk size of 100. The chunk size literally mean how many smaller pieces do you want to split this PDF file into. So you have a PDF file you've read, and this gives you a PDF file with different pages. So with the different pages, how many chunks do you want to separate them into? Okay, and we can also specify the chunk overlap, and chunk overlap we can just send it to 40. So with the chunk overlap, let me just quickly open this PDF file and let's see something. So with the chunk overlap, let's say the first chunk of your PDF file is from here to this full stop right here. So when you use chunk overlap and you specify some number, that means that the next chunk should start from here. But once we are specifying chunk overlap, the next chunk is going to start, let's say, from here, and it will have some of the text from the previous chunk. So this is going to help your system to also get more information. So that's why we are just specify the chunk size and the chunk overlap. So now we can get our pages right here, or the chunk pages right here, and we say this is equal to splitter.split underscore document. So we are going to split the document, and the document we are going to split is our pages. So you can see we are reading in our pages here. So now we are going to split these pages into different chunks. Okay, and to be curious, we can just check these pages and see how long these pages are. So these are all the pages we are having, and you can see how long it is. So this is the entire document that we are reading, and we are separating them into different chunk size. So we can, let's say, access the first chunk by just using list indexing, and this is the first chunk in our data set. Okay, so it's easy. You can access maybe the third chunk. You can access any chunk that you want, or you can even check the maximum length of how many chunks your data has been splitted into. Okay, so this is all about splitting. Now we learned how to take our data, we learn how to split it into different chunks. The next thing we are going to do is to send these pages into a vector database. Okay, we will store this in the database, whereby when we ask the question, the LLM can go into that database and retrieve the answer for us. we got our embeddings and we are sending these embeddings to this database right here. So that anytime you send a question, the question will come and search for the relevant document that correspond to that question, and then the LLM can now retrieve that particular chunk of information, and based on that chunk it will give you a response. There are a lot of vector database around, but in this particular tutorial we'll be using FICE. I think if I'm pronouncing that correctly, that's from Facebook. We have FICE, and you can also use Docker array or Docker array memory search. Any of these that you want to use, you can use any of them. So I will just initialize the vector database on the go. So we call it vector underscore storage, and this is where we'll be storing our documents. So this will be equal to files dot from documents. So in a vector database, the documents we are reading, they are in string form or they are in string representation. So vector database deal with embedding. So before you send in your data, you have to make sure you convert this data into embedding. So for that, you have to use the OpenAI embeddings. There are other embedding methods, but we'll be using the OpenAI embeddings. So we have to just make sure we send in our pages, and also we give it the OpenAI embeddings. So our pages will be converted into embeddings, and embeddings, I've treated this on this channel. I think I have a tutorial on how embeddings work. So if you want to understand more about embeddings, you can just check it out and watch it out for yourself. So we convert it to OpenAI embeddings, and then we can save it into our vector database. And right here you can see we are importing the embeddings from OpenAI. We are also importing the vector database from OpenAI. So we are importing all these styles before we are using them. So you have to make sure you first import them before you use them. Okay, so this will go ahead and store this in our vector storage, but we need to create a retriever out of this so that we can be able to retrieve any information. So the retriever will help the LLM right here. You can see retrieve context to retrieve the important context based on our query. So that's what we are going to do. So we call this our retriever, and this retriever is equal to our vector storage dot as retriever. Okay, so now this will go ahead and retrieve the important information for us anytime we want to retrieve any information based on this context. So let me run this, and so this will take some time to set up your vector storage and then convert all your documents into embedding and create a retriever out of this for you. The next thing we have to do is to create a prompt template. So prompt template is like a template that gives the LLM instruction on what to do. So we are going to create this template to tell this LLM, okay, go ahead and answer questions, but these questions should be based on the document I've provided with you with, the data I have provided you with. Don't do anything outside my data. So let's go ahead and create the prompt template. And to create that, you can see we've imported prompt template right here. So from langchain.prompt, we've imported prompt template, and that's what we'll be using to create our prompt template. So we'll go ahead and just let's call this our question underscore template. So this will be equal to this, and over here we can tell this LLM to answer questions based on whatever context we are giving it. Okay, so our instruction we are giving to this LLM is that you are a smart bot that answers questions based on the context given to you only. You don't make things up. So we are telling this LLM, or we are instructing this LLM to answer questions, but based on this context we are giving it. So now let's go ahead and give it the context. So we can see our context, and we'll just put in context here, and we'll also be giving it a question. So this LLM will answer question based on the context and the question. So you give it a context and a question. Okay, so at the end, this prompt template will take in a context and a question, and this will be sent to our LLM to answer our questions based on the context. So this the instruction template we'll be using. And from this instruction template, we can create a prompt template, which we'll call prompt. And this prompt here is equal to prompt template dot from template. And inside here, you have to give it your template we've created. So the template we created is called question template. So we just give it a question template. Okay. So this is the template we've created, and we are sending this template into our prompt template. Okay. So this prompt template now will go ahead and take a context and a question, and based on this context is going to answer your question. You can go ahead and format this prompt template to see how it looks like. So we can say prompt dot format, and in here we'll give it the context and the question because that's the input to this prompt template. So we'll go like context. Okay, we don't need this. And the next one will be the question, and we'll tell it to answer this question based on the context. So that's what we are telling this template. So we'll give it, at the end of the day, we are going to give it a context and we'll give it a question. Okay, so we are going to tell this LLM that, hey, here is the context, and based on this given context, answer me this question. Okay, so the context will be the file we've read that we are with the file we've read into our vector database. That will be our context. So our context is the PDF file we've read into our vector database, and based on that PDF file, this LLM is going to take a question and answer based on only that PDF file and nothing else, because we've told it to answer questions based on the file only, or based on the context provided only. So we can even go ahead, and do we need to print it? No, we can even run this, and we had some name error, question template is not defined. That's because we didn't run this line. So I'll run this once again, and you can see, okay, you are a smart bot that answer questions based. So you can see how the prompt template have formatted this in the right way. I can go ahead and print it for it to look nicer. Okay, so you can see you are a smart bot that answers questions based on the context given to you only. You don't make things up. Here is the context to use. So this here is the context to use will be our PDF file that we've stored in the vector database. Then question, answer this question based on the context, and this question is the query coming from you, the user. Okay, so it will use that query and go and retrieve the relevant information from your vector database, and based on that relevant information, the LLM is going to answer you. Okay, so I think we can just give some spaces here in order to format this in the right way. Okay, so now we are one step ahead. We've created this prompt template, we've stored our pages in the vector database. Now all we need to do is to go ahead and chain all of these things up, because we are using Langchain. So we have to chain all of these things up so that it takes the question, send the question to your model, then based on that question, the LLM will also answer you. We'll be using the runnable pass-through and the runnable parallel. So we'll be using these two libraries here from Langchain to take the question, and based on this question, we can retrieve the relevant information and answer the user. So over here, I will say our result is equal to runnable parallel, and inside the runnable parallel, we are going to provide a context, and our context is equal to our retriever. Then we'll also provide in the question, and our question will be equal to runnable pass-through. Okay, so let me explain this. So before we'll be able to prompt this LLM based on this question is what is going to retrieve. So let me open up. Before we can prompt this LLM, our query, which is the same as our question, is what is going to retrieve this relevant information. And this same question will also go into the large language model. So our question at the end of the day is going to two places. It will go and retrieve the relevant information based on the context provided, and it will also go ahead and tell the LLM to answer it based on the context the LLM is also having at the same time. So that's why we are using the runnable pass-through here, because this will take our question and pass it both into our vector database or our retriever to retrieve the relevant context, and also pass it into our model for the model to also give us the right response. So that's why we are using runnable pass through. We are running everything in what? Parallel. So we are using runnable parallel in this case. So I'll go ahead and run this, and at the down here we can now come and chain everything up. So now our final chain will be something like this: result, and this result will go into the prompt, and the prompt now goes into the model, and the model will go to the parser, because the parser will give us only the string output. If you could remember, what the parser is doing here is that it helps you to get only the string and not the AI message. Okay, so at the end of the day, we are just chaining everything together. We are chaining our result, and this is the result of the contest and the question. So we are taking the question and the contest together, and we are running through this through the prompt. This will go and retrieve our information from our vector database and give this information to the model, and based on that information we are going to get the right answer through our parser. Okay, so you can see this is the effect of Langchain. We are chaining everything up. So here I can just do chain dot invoke, and over here I can write something and see if that is really from our document. So for instance, let's just ask it what is coding once again, and see the result it will give us. So just look at this answer. In the context provided, coding refers to the process of assigning appropriate codes in the acute care setting, particularly in relation to malnourished patients for the purpose of detecting and management. So you can see how brilliantly it's answering this question based on the context we have given it, even though this is not what coding really means, but it's giving you what coding means based on the context you've provided it. For instance, you can see the answer it gives us when we ask what is coding right from the beginning, and this is going to the LLM only. We've not given it any context. It says coding is the process of using the programming language to create instructions that tell the computer blah blah blah. So this is the right thing about coding, but because we are now giving this LLM context and we want it to answer the question based on our PDF, this is giving us what coding is based on the PDF provided. So what I'll do is that I'll now go ahead and ask it a question I know is in the PDF, and I know what the answer is, and see how it will answer that question. So I'll do like so the algorithm used to determine nutrition in children of type is artificial neural network. Okay, so it's saying it's what artificial neural network. Let's run the same thing again and see how it will answer it over and over again. Okay, so it's the same answer, artificial neural network. So this is the answer right from what the PDF or the file we've provided to this particular model. In order to know the exact page from which this LLM is answering you, you can use your retriever to get that. So you can use retriever.invoke, and in here you can give it that same question. So we can copy this same question, and this will return to you pages from which this LLM is answering your question. So you can see it's getting the answer from these particular pages. And this is one great thing about RAG. Okay, it will answer you based on the context you've provided, and it's going to answer you and give you the pages from which it's even generating these answers for you. So our LLM is taking these pages, and based on the information in these pages is returning to us the answers. Okay, we can also ask it right here, maybe who is the author of the paper. So let's ask that question and see what it will bring up. So you can see, I'm sorry, but I cannot provide the author of this paper based on the context given. Yes, so that's right. So it doesn't know the author of this paper because that is not in the context we've given it. Okay, so this is how great RAG systems can be. This is how great LLMs can be when you have given them additional information, or you have given them additional context to work with, not only depending on their knowledge, which can be misunderstanding or can be deceiving sometimes. Okay, so guys, this is all. I'll make sure the code will be on GitHub where you can leverage it and practice with it. Also, if you love it, just give me a thumbs up and share for someone who this might help. Thanks for watching, and as usual, I'll see you in the next tutorial.